At the virtual MRS Spring Meeting 2022, the materials science community gathers online to discuss new developments and research in materials science. The meeting program explores a wide range of topics from morphing materials, photocatalysts, biomaterials, and much more. And MRS TV is right here bringing you all the latest from the virtual meeting. Welcome back to MRS TV 2022 for our virtual show. As attendees everywhere gather online, we're here to connect with some of this year's thought leaders virtually. We speak to some of this year's meeting chairs about the virtual offering. The MRS Awards Committee Chair tells us more about the awards program. We hear more about new and exciting developments in material science from research organizations around the globe. The symposium ex-speaker, Benjamin T., tells us more about his amazing wearable sensors. We speak to the postdoctoral award winner about his research into ceramics. And we learn more about the importance of diversity, equity, and inclusion in materials research. As you can see, we have an exciting program coming up, so stay tuned for our first interview. You're watching MRS TV. Next, let's talk to one of the organizers of the 2022 Spring Meeting. Now, the in-person version is completed. We're on to the virtual meeting, but looking back at the in-person conference, how did it go?
So the Hawaii meeting was really amazing. I think there's a real buzz and excitement amongst the participants of the meeting. I think for many graduate students, it was the first in-person meeting that they've attended. For academics like me, it was the first large in-person meeting that we've attended in a couple of years. So I think just meeting old friends and reconnecting, talking science in a location like Hawaii was really fantastic. And I think everyone enjoyed the meeting, and I think it went off really successfully.
This week, we'll see a large number of virtual sessions. What's the importance of having this virtual component to the meeting?
Yeah, I think the virtual meeting is really important and exciting because it allows those delegates that are not able to come for the physical meeting, be it for financial reasons or because of the pandemic and COVID reasons, they're still able to participate in an MRS meeting virtually. And so I think, beyond the pandemic, virtual meetings are here to stay because it does allow access to a much broader audience, especially from countries where they may not have the financial resources to attend a meeting in person. So I think it's really a wonderful opportunity for everyone to be engaged with the MRS and participate in the MRS meeting and get the experience virtually.
What are some of the things you're looking forward to during the virtual meeting?
Yeah, I'm looking forward to catching up with those academics that were not able to come to Hawaii in person. I think the program is very exciting. There are exciting talks, including the Symposium X talk that will take place at the virtual meeting. The invited talks are really excellent. So I think the virtual meeting is and will be as exciting as the in-person meeting. So I'm really looking forward to it.
And looking back at your time as a meeting chair, tell us about the experience. What advice would you give for future chairs?
Yeah, so being the meeting chair for an MRS meeting is really rewarding. It's a lot of work, of course, but I think seeing the amount of effort it takes to organize a meeting of this magnitude, gives you a good perspective for when one attends a meeting, you don't really realize how much work that goes into organizing a meeting like this. So that was really rewarding for me. It's a heck of a lot of work, but it's worth it. It's a good way of giving back to the community. I mean, in terms of advice for future meeting chairs, I think there's a opportunity to influence a meeting, around themes that they consider to be important by inviting the plenary speakers and symposium speakers around a particular idea or concept that they're interested in. So yeah, it's a rewarding experience, and the amount of effort it takes is certainly worth it. And I strongly encourage people to volunteer to become meeting chairs.
And I'm joined by MRS Awards Committee Chair, Saveen Mataldu. Good to see you. And tell us a little bit about the MRS Awards program, its purpose, and who can be nominated for an award.
The MRS Awards aim at recognizing the best and the brightest within our materials research community, all the way from early career professionals in their graduate school years up to the most pioneering scientists in our field. The awards are open to anybody, and they're specifically targeted to give anyone who makes contributions in our field opportunities to be recognized both internally within our community, but abroad and within their companies and places of work.
We typically think of career-oriented awards as being strictly for those who've been in a given field for a fairly long time, but are there MRS awards for materials scientists who are in different phases of their career?
We have specific opportunities across the whole span of what people work on within our community. At the earliest level, we have the Graduate Student Awards. At the highest level, we have something like Von Hippel Award for pioneers in our community. But in the middle, we have recognitions for activities related to diversity, education, and inclusion, our Impact Award. We have a new Renewable Energy Award targeting those who are making impacts in renewable energy. We have early career and mid-career recognitions for those at different portions of their career. And then we have a variety of other awards for things like publications and communications that are available to anybody who is nominated.
And who can nominate a deserving individual for an award? Where can they find out how to begin the process?
For the most part, anybody can nominate somebody else for an award for MRS, but the specifics are all listed quite clearly at mrs.org/awards. In some cases, you may want a senior person in your community to be able to nominate you for a more senior award. But by contacting our committee, even if you were not able to do that yourself, we can help you find someone that can put together a compelling package for someone you think deserves recognition. So if you're interested in nominating someone for an award, please consider that there is a huge breadth of diversity within our community. And MRS would like to see applications from communities that have been traditionally marginalized, including women, Africans, African Americans, Hispanics, Native Americans, LGBTQ+. We need to recognize those people within our community and bring them up and show their achievements. So if you know somebody from those groups that's doing excellent work, please do not hesitate to put them in so we can represent our broader community through our awards.
And what is the importance of earning an MRS award in an individual's career?
The importance of earning an MRS award for an individual's career can be huge, and it really depends on where they are in their careers. We definitely see a tracking of those who win awards and those who are successful as their careers move on. But for the most part, it allows the diverse community that we have to be recognized internally, but perhaps it provides their companies or their universities or their places of work or even their family members with an external representation of their achievements and what they've been able to do to make the world a better place through materials research.
Now let's take a look at some of the latest developments in the world of material science. The Center for Integrated Nanotechnologies, a Science National User Facility, offers opportunities for students and researchers at its two New Mexico facilities, Sandia and Los Alamos National Laboratories. Let's find out more.
There is no better place to build a scientific career than a national user facility.
It's a really exciting environment to do research. CINT stands for the Center for Integrated Nanotechnology. We have two facilities, one at Sandia National Laboratories and our Gateway facility up at Los Alamos National Laboratory.
This is a really exciting time for nanomaterials research, and that's because there's a demand for new materials at the national level.
To get access to CINT, all you need to do is write a 2- or 3-page innovative science proposal or nanoscience proposal that it's reviewed externally, and then once that proposal is accepted, then you're able to access all the capabilities at CINT for free.
What I really enjoy about being in this CINT environment is having experts in anything you can think of right around the corner from your office.
The Center for Rational Catalyst Synthesis is an NSF Industry University Cooperative Research Center. Faculty at 3 universities receive funding from 17 companies to do pre-competitive fundamental research to elucidate the chemical fundamentals of heterogeneous catalyst synthesis.
Catalyst preparation has been called a voodoo science. You have to use the right incantations and spells to get the right formulation. And so our goal in the Center for Rational Catalyst Synthesis is to turn the art of catalyst preparation into a science.
The opportunity to collaborate is a really important aspect of not only what we're doing in research, but the mission of Circus.
The whole concept is we do academic fundamental research that's driven by technological need and opportunity.
The Center for Rational Catalyst Synthesis is a wonderful place for people to develop new ideas and to cultivate new ideas.
At Tsinghua University in Beijing, research into flexible electronics has been at the cutting edge, focused on the design and fabrication of flexible integrated circuits. Let's take a closer look.
Our group has been working on flexible electronic technology for more than 15 years. More than 180 patents have been authorized. In the past Olympic Winter Games in 2022, we developed a wearable chest strap to help the athletes in monitoring the body temperature, ECG, and location in real time.
Flexible circuit manufacturing technologies produced flexible rotation monitoring system, conformally attaching these systems into rotation parts.
All the work we did required experts from different fields. We cooperate with them in a multidisciplinary approach.
Batch production of lab demos from Tsinghua University can be realized in IFET with 8 small-scale pilot production lines. Tsinghua University and IFET will be the pioneer in bringing flexible electronics to common users, who will benefit a lot from this technology.
The Center for Sustainable Materials and Innovation is a new scientific and technological innovation hub. The hub aims to solve some of the most pressing sustainable development goals around materials design and the circular economy.
The Center for Sustainable Material and Innovation started from the very core concept of how we think about material. And our goal is to have a radical shift in the way we design, we engineer, and eventually manufacture material to add the sustainability consideration into play. Today, when we make material, we think about the efficiency, the durability of the material, but there is no information about the sustainability figure of merit. So, for example, how much energy it takes to reuse the material or recycle the material, and what is going to be the environmental impact. So with this center, we want to really rethink the way we make materials and have sustainability as one of the key parameters in the way we design them.
And joining us now is Benjamin T. He's from the National University of Singapore. Good to see you. And your virtual Symposium X talk is actually titled AI Skins for Good. Give us a preview.
Sure. So what I'll talk about is how we can combine material science and engineering to develop devices that AI algorithms can take advantage of for wearable health applications as well as for prosthetics or neural applications.
And researchers have been working on stretchable electronics for some time. Your work expands on that to include reading and interpreting what could be massive amounts of data from wearable sensors. How do we process all that data, and what can be some of the benefits of doing so?
Yeah, I think that's a great question. I think that processing very large amounts of data is becoming very important as we're making these devices a lot more sophisticated. They can collect a lot more signals in a multiplexed manner. And we will have to work with neural algorithms that can filter and process this data very quickly and, importantly, power efficiently. Because otherwise, you will end up having to wear a very big battery, which obviously becomes, makes it unwearable. So that's also really where I think working with neural machine learning algorithms, and even newer ideas around how we can collect this data and then sort of feed that back into device design and materials engineering. That is very important.
What led you to studying this area of materials science?
So I got fascinated by the idea that a computer can be flexible, stretchable, or even soft like skin. During my undergrad research program when I was studying in University of Michigan, where I was developing an inkjet printable semiconducting inks that can be put onto plastic substrates, and that kind of got me started thinking about, wow, I can actually, through material science, using neural materials, make them compute, right? And my background is in electrical engineering, which can be quite dry and boring, but the material science aspect of that really fascinated me and drew me to that, and that's how I got started looking at flexible electronics and flexible devices.
And what are the next steps or the next discoveries still out there that you'll be working on?
Yeah, I think that I'm increasingly very interested in the field of medicine, right? And I'm also starting to look at, actually we are already collaborating significantly with clinicians interested to make use of some of our materials, new kind of materials, new kind of devices, right, that can help them improve their clinical practice and collect the kind of relevant data that can improve their patient outcomes, right? And so that's kind of where I'm very interested in working very closely with clinicians. But creating any new medical technology requires a longer lead time because of regulations. But it's a good start when you start talking to doctors and uncover problems that they face.
We're MRS TV, your daily news show featuring interviews and discussions on hot topics in material science from this year's MRS meeting. You can catch us on the virtual MRS meeting platform, the MRS website, and on YouTube. And you can join the conversation on social media, so stay tuned for more. I'm joined by Mattia Bisous, a postdoctoral award winner. Good to see you and congratulations. And your citation reads, for fundamental contribution to the knowledge and development of flash sintering phenomena and processes in ceramics. Tell us about your work.
As you probably know, ceramics are strongly binded to fire, let's say, because the typical production process takes place as follows. So you start from some powder, the powders are shaped in a so-called green body, and then the green body is fired to get a dense ceramic component. And the binding between ceramic and firing is so strong that even the word ceramic means to fire. It derives from the Greek keramos, that means to burn. And what we are doing the last few years is to try, let's say, to develop processes where we use electric field, electric current, electromagnetic radiation, external pressure, and specific additive to decrease the sintering temperature. So to promote the consolidation of ceramics at a lower temperatures with a lower energy consumed.
And what about this particular field of materials science drew your interest?
First of all, I would like to say that I like to be a researcher because it's even though we are working in a scientific field, I would say it's something quite artistic, quite creative. So it's something I think very interesting, very funny for everybody. But I like more specifically ceramic sintering because it is a miscellaneous process, I would say. It's well established because of the first sintered artifact dates back to 25,000 years ago. It is basically the first industrial process discovered by the mankind. And but there is still quite a room for fundamental science for studying the mechanism, and studying sintering involves different fields of material science, also chemistry, mechanics, surface chemistry, defect chemistry, charge and mass transport. So it's quite various and interesting.
What are some of the practical applications, such as devices or products, that might come about as a result of your work?
The main goal is to reduce the energy cost of sintering, which is a very energy-intensive process because it is typically carried out between 900 and 1200 degrees C for traditional ceramics, but even at temperature exceeding 2000 degrees C for advanced ceramics. So the main goal is to reduce the energy, environmental, and economic cost of sintering. And what's more interesting is that by decreasing the temperature needed for densification, we can also produce new materials because we can densify phases which would be metastable, which would decompose at high temperature. We can densify volatile materials, metastable defect chemistry. So we can obtain materials with properties which cannot be attained by conventional processes.
That's it for our show at the virtual MRS Spring Meeting 2022, and we hope you enjoyed our program. If you've missed any of our shows from Honolulu, you can catch up on the virtual platform and on YouTube. We hope to see you again at the MRS Fall Meeting in Boston or online. Until then, aloha.